Hi guys, welcome back. We're going to do section B today, and we're going to talk about currents. Okay, so a current is just basically kind of a consistent flow of the sea, of seawater, when it would typically be relatively stationary. And what happens is the surrounding water is very stationary, and so you get this current that flows through for many different reasons. Again, going back to Finding Nemo, the East Australian current, that's what Crush gets into. And it's literally like it's like that. It's a stream of water surrounded by still water that moves for different reasons. Okay, so surface currents close to the surface, are strictly caused by wind, and we have these things called global winds, which are big regular winds. Cold air blows down from the North Pole, up from the South Pole. Moderate and kind of medium winds blow closer to the equator and so on. And so we know these certain winds, but these winds curve, okay? This thing known as the Coriolis effect, because the Earth rotates, okay? It actually goes this way. No, it goes this way. Okay, doesn't matter. So if I've got wind blowing down from the North Pole, okay? Or actually, let's see what you can see easier. We'll do it from the South Pole, okay? If the Earth isn't moving, that wind goes in a straight line. But if the Earth is rotating, okay, let me give it a good spin, that wind makes a curved line, okay? It doesn't follow a straight line. It follows the curvature of the rotation of the Earth, okay? So that Coriolis effect actually causes the currents to curve and the winds to curve because the Earth is always spinning, okay? Now we get these regular currents in these patterns known as gyres, okay? And they're circular currents because of the basins they're in, because of the shape of the basin. And I'll show you that a little bit more on the next page. I've got another map to show you. And then just smaller little circular currents are called eddies. They can happen in more local regions, okay? So here's a big world map. And you can see these gyres, and they've got names, and they're named after the basin that they're in, okay? So you've got this cold current coming up from the South Pole, and it bumps into Africa, okay? And it gets closer to the equator, which is warmer, and so it warms up, and then it bumps into South America, and so it curves this way. And so because of the shape of the basins, these different temperature currents follow roughly a circular pattern, okay? Here's the North Atlantic. It's bringing down cold water from the North Pole, bumps into Africa again, kind of turns a corner, starts picking up some heat from the equator. And so it starts moving. Oh, it hits North America, and then it curves this way, okay? So those are gyres. Those are some of the basic ocean currents, okay? Now, these currents have a big effect on the climate all over the world, okay? The sun heats up the water. It heats up the ocean, mostly at the equator. But then these currents carry away something like a third of that energy that's been deposited at the equator. It doesn't stay at the equator. It moves somewhere else into the globe, okay? And then the global winds come along, and they move the rest of that energy from the surface water. So if you have warm water, warm surface water, the air above it is also going to be warm, and the winds will carry that warm water. If you have cold surface water, the air above it will be cold, and those global winds can move that cold air, okay? One of our kind of main currents and air bands is known as the Gulf Stream, okay? And what it is it's warm water coming from the Gulf of Mexico, and it moves up towards Europe, okay? So Gulf of Mexico is really close to the equator. It's nice and warm down here, okay? Because of the shape of the basin, because of these global winds, it starts moving in this direction. It's warm water, and so as the global winds move across it in this direction, it carries that warmer air into Europe right here, okay? And so the climate in Europe is actually warmer than the climate in New York. Even though this is farther north and it should be colder, because the farther north you go, it's colder, because these global winds are picking up some warm air from that Gulf Stream, it heats up that part of Europe, okay? Crazy, right? So there you go, wind blowing picks up the warm air. This also happens from the coast of Asia, along the coast of Japan, actually. in this other current known as the Kuroshio current. So we've got a warm current moving up in this direction. And then the global wind is blowing along, and it actually kind of starts to hook around here. And so the warmer air from that current actually heats the west coast of Canada to a much warmer temperature than this part of Siberia and Russia, which is straight across it. Okay, Siberia is like frozen like all the time. And a lot of Canada is really frozen. It's pretty far north. Okay, the farther north you get, the colder it gets. But that west coast of Canada is warmer because of that air flowing over that warm current of water. All right, we get some other kind of funky currents happening. First, we've got this thing known as an Ekman spiral, and it's really kind of complicated. But what happens is as the surface water is moving because of the wind, it actually drags the deeper water along with it. But there's so much friction down there because there's more water. The deeper water moves more slowly. Okay, so you have the surface water moving along, and it's pulling the water below it, but it's going a little slower. And it's pulling the water below it, and it's going a little slower and a little slower. And because of that different speed, it actually starts to curve the current a little bit. And so you get this kind of spiral turning of the current as you move deeper. And it has some pretty strange effects on things, okay? We also get these two occurrences known as upwelling and downwelling, okay? So with upwelling, if the surface water is being carried away by wind, so let's say you've got a bunch of wind blowing in this direction, and it's actually blowing the water away from the coast. It's almost like it's creating a low tide. Since there's less water pushing down, the deep water is able to rise up in its place. Okay, so the warmer surface air water moves out of the way, and cooler deep water comes up in its place. This is why sometimes the beaches are so cold. But then you also have the opposite, downwelling. Okay, so if the wind is coming this way, it's going to bring more water in, and the surface is actually going to rise. You're going to have a higher tide. That weight of the water is literally going to push the rest of the water down. Okay, and that's known as downwelling. Crazy stuff. People study this. It has an effect on things. It has an effect on weather, on tides, all kinds of stuff. All right, finally we get these deep currents. The currents we talked about already were surface currents, okay? So subsurface currents below the surface are affected by things like that Ekman spiral, that downwelling, upwelling, all that stuff. Density differences, and I'll show you that difference in just a second, but not wind. Okay, those global winds have no effect on these subsurface currents. Okay, so a density current is a current that has different temperatures or different stuff in it. Okay, remember we talked about the saltier the water, the more dense it was. Well, the colder the water, the more dense it is. Cold water huddles together and it gets really dense and it sinks. Whereas warm water wants to spread out like hot air rises. You know, warm things like to float. Okay. So I'm going to attempt to show you this. Actually, I'm going to show you right at the very end. Let's look at these thermohaline currents and the turbidity currents, okay? So a thermohaline current is both cold and salty. And you can see this deep current here. Both of those things make it very dense. The cold water makes it dense, and the fact that there's a lot of salt in it makes it dense. As it starts to move up here, though, it starts to warm up because it goes through the equator. And so it becomes less dense, and then it becomes a more shallow current. That heat gets transferred to the air, it cools down, and it sinks back down. We've got this current that switches between a shallow and a deep current in this pattern, okay? Turbidity currents are currents that are filled with sediment for some reason. So just like water that's filled with salt is more dense, water that's filled with sediment is more dense. And so those will be a deeper current, okay? All right, let me increase the size of my camera here. So hopefully you can see this, all right? So I've got warm water, that's red, and I've got cold water, okay? Warm water floats, it wants to go to the top, cold water sinks, okay? So I'm gonna put this cold water on top of the warm water, and you can watch to see what happens, okay? There we go. Okay, can you see the color changing? Here, let me put something white behind this. There you go. You can see it a little bit better. Okay. You can see the red is starting to get some blue in it. The cold water on top is more dense, and so it's pushing down. Now it only has so much room, and so it's actually going to start causing that red to go up. And you can kind of see these little wave patterns in here, these little currents. Okay. Eventually it will even out and become equal, but you can see how the neck of the bottles are starting to turn purple. It's because the red's going up and the blue is going down, and they're starting to mix. Okay. So convection currents, we'll learn more about those as we go. All right. That is all I've got for you today, I think. Yep. See you later.